Imagine a place on Earth so alien, so utterly hostile, that it defies our very understanding of life and geology. Not on Mars, or in the icy depths of a gas giant's moon, but right here, beneath the shimmering surface of the Red Sea. We're talking about the Atlantis II Deep, a colossal brine pool that is boiling, super salty, and rich with metals, creating an environment unlike almost anywhere else on our planet. Today, we're counting down the top 10 reasons why Atlantis II Deep is not just extreme, but a true enigma, a place that continues to astound scientists and challenge our assumptions about life itself. From its immense pressures to its hidden treasures, prepare to plumb the depths of one of Earth's most incredible deep-sea mysteries. This is what makes Atlantis II Deep so extreme. Our journey into the Red Sea's inferno begins now. Our countdown begins not just with depth, but with a unique geological setting, the very birth of an ocean. Number 10 on our list is its sheer depth within a nascent ocean basin. The Atlantis II Deep lies nearly 2,200 meters, or 7,200 feet, below the surface, in a region where the Arabian and African tectonic plates are slowly tearing apart. This process, known as seafloor spreading, is creating a brand new ocean, and in doing so, forms incredibly deep, narrow basins and trenches. Imagine a rift valley on land, now submerged and vastly expanded, a colossal tear in the Earth's crust. Number 9, the Red Sea itself is a nascent ocean, a geological hotspot of monumental scale. It's not a fully developed ocean like the Atlantic, but rather an oceanic rift in its infancy, characterized by intense volcanic and hydrothermal activity. This continuous stretching and thinning of the crust creates the perfect conditions for magma to rise close to the surface, heating the surrounding rocks and driving complex chemical reactions. It was in the 1960s that the true scale of the Red Sea's hidden wonders began to emerge. Number 8, the early expeditions aboard research vessels like the Chain and the Meteor, meticulously mapping the seafloor and collecting samples, uncovered these unusual deeps. They weren't just deep holes, they were filled with incredibly hot, dense water. The discovery of these brine pools, particularly Atlantis II Deep, changed our understanding of oceanic geology and the potential for mineral formation. How did this extraordinary hot, salty pool form? Number 7, it's the result of vigorous hydrothermal activity. Seawater seeps down through cracks in the seafloor, gets superheated by the underlying magma, and reacts with the volcanic rocks. This process strips metals and minerals from the rock, and the superheated, metal-laden water then rises back up, pouring out of vents on the seafloor. But instead of mixing with the surrounding cold seawater, its extreme density causes it to settle, forming distinct pools. What makes Atlantis II Deep truly unique, and our number 6 reason, is its multi-layered brine pools. Unlike a simple pool, Atlantis II Deep is stratified into several distinct layers, each with different temperatures and salinities, like a stack of liquid pancakes. The densest, hottest, and most mineral-rich brine sits at the very bottom, isolated from the cooler, less dense layers above. Think of it like a giant, naturally occurring chemical separation tank. But it's not just the layers, it's the sheer density and saltiness of these waters. Number 5, the extreme salinity. The brine at Atlantis II Deep is up to 10 times salter than normal seawater, making it so dense that it would instantly float a person. This incredible salt concentration creates an environment where most marine life simply cannot survive. And then there's the heat. Number 4 on our list, the extreme temperature. The bottom layer of Atlantis II Deep reaches a scorching 68 degrees Celsius, or 154 degrees Fahrenheit. That's hot enough to boil an egg, and it's a constant, geothermal furnace at the bottom of the ocean, a truly volcanic cauldron. Number 3 on our list takes us into the very composition of this lethal cocktail, the toxic heavy metals. As seawater circulates through the superheated rocks, it picks up vast quantities of dissolved metals, iron, manganese, copper, zinc, silver, and even gold. These metals precipitate out of the brine, forming thick, muddy sediments on the seafloor, creating what is essentially a massive, naturally occurring ore deposit. For decades, this mineral wealth has tantalized scientists and commercial interests alike. Imagine finding a natural treasure chest at the bottom of the ocean, potentially containing billions of dollars worth of metals. In the 1970s and 80s, there were serious proposals to mine these deep-sea muds, with exploratory efforts even attempting to pump the brine to the surface to extract the valuable minerals. However, the technical challenges, the immense depths, the corrosive nature of the hot brine, and growing environmental concerns ultimately halted these ambitious plans. The sheer scale of the operation, and the potential ecological damage to such a unique and fragile ecosystem, proved too great a hurdle. Yet, the metals remain, a silent testament to the powerful geological forces at play, and a potential resource that continues to spark debate and research. Which brings us to number 2, life, thriving against all odds. In an environment that is boiling hot, incredibly salty, and saturated with toxic metals, you'd expect nothing to survive. Yet, Atlantis II Deep is home to a unique ecosystem of extremophiles, microbes that not only tolerate these conditions but actually thrive in them. Scientists have discovered communities of bacteria and archaea living in the brine and the surrounding sediments, feeding on the chemical energy derived from the hydrothermal fluids. These are creatures that have adapted to a world that would instantly kill almost anything else. Imagine microscopic organisms, evolving to consume metal compounds, or to withstand temperatures and salinities that would rupture the cells of conventional life forms. They represent the ultimate survivors, offering us a glimpse into the very limits of biological resilience. Studying these extremophiles helps us understand how life might have originated on early Earth, or even how it could exist on other planets or moons with similarly extreme conditions. These are not just scientific curiosities, they are living laboratories, providing insights into the fundamental processes of evolution and survival in the most inhospitable environments imaginable. So, what could possibly be more extreme, more compelling, than boiling, metal-rich, super-salty water teeming with impossible life? The ultimate reason Atlantis II Deep stands as one of Earth's most extreme places, and our number 1, is its significance as a scientific frontier and a potential future resource. Atlantis II Deep is a natural analog for early Earth conditions, a window into our planet's primordial past. By studying its unique chemistry and biology, scientists can piece together clues about how life emerged from non-living matter and how oceans formed. Furthermore, the immense metal deposits still represent a tantalizing prospect for future resource extraction, though the environmental implications are profound. The challenge lies in balancing the potential for economic gain with the imperative to protect this unique deep-sea environment. Future technological advancements might make extraction viable, but the ethical debate will undoubtedly intensify. Atlantis II Deep forces us to confront fundamental questions. What are the limits of life? How do we manage Earth's finite resources? And what mysteries still lie hidden in our own planet's depths? This extraordinary brine pool reminds us that even in our own backyard, the deep ocean holds wonders and challenges that continue to push the boundaries of human exploration and understanding. What other extreme places do you think deserve this kind of deep dive? Let us know in the comments below, and don't forget to like this video and subscribe for more journeys into the extreme frontiers of our world. Until next time, keep exploring the mysteries beneath the waves.